Welcome back to Connect and Transform. We're picking up where we left off, creating a graphing SVG. We're going to start off by creating the series labels, and then we'll work on formatting the axis and data values, and then if we have time, we'll get to the automatic scaling of the y-axis. So hopefully by the end of the video, the only things left will be related to the tooltips, and then the actual computation of the graph data itself. So as we're placing series labels, we're going to have an X and a Y offset that we're going to manipulate as far as positioning our labels names, which are text elements, and then the colors, which will be rectangles. So we're just going to have a variable LX, which is going to be initialized to 1160. And then ly. And then we're going to create our top mask. That's one of the things that we did in the most recent video. So we're going to create some elements that actually reference that now. So we're going to have a mask element, which is going to be a rectangle. And then we're going to set some attributes. So we're going to set width and height and fill. And then we're going to append this to the graph element. So for the width, it's going to be 1200, which is the total width of the canvas. For the height, it'll be 64. The fill will be a reference to the top mask linear gradient. And then we're going to create our labels, series labels container. And that is going to be a group. So replace rect with G there. Now we're going to set a few attributes of this. We're going to set the ID. And we're going to make the ID be series labels container. And then we're also going to append that to the graph element node. Okay, and then we're going to have a loop. And the purpose of this loop is to go through each series and then place its name and its color. I'm looking here for something like this. There we go. Just saves a little bit of typing. So all that is a loop on S for each series in the graph data. So once we're in the loop, we're going to be creating a series label. And that is going to be a text element. Okay, and then we're going to set a few attributes of our text. We're going to set an ID, X, Y. So yeah, we're going to set an ID. We're going to set X. We're going to set Y. And that's just going to be our offset variables, LX and LY. Our ID can be series underscore, and then we're going to use the name of the series. And then we're also going to set the text anchor attribute to end, so that will write justify it within its container. And then we're going to create a text node and append it as a child. And the value of that text node is also going to be the series name. Okay, and then we're going to append this to the series labels container. So let me grab that ID, put it in that query, grab this element that we're creating, and make sure that it goes there. Okay. All right, so that will have created and attached our series label. So now we have some code to read the width of the label, because the name is going to be of a different length every time. So we got to figure out how long it is so we can figure out where to position the other elements. So that's going to be, it's just going to be series label dot get bbox dot width. Then we're going to do a check to see if we need to reposition our series label and start writing things on a second line. So we're going to be doing some math, and we're going to be saying if the position of our offset is less than 80, and if you recall, 80 is the leftmost edge of the graphical portion of the total canvas. So whatever is in these parentheses is going to be basically the cursor, the X position of the cursor. So that's going to be LX minus our width W minus, and then there's going to be a couple constants in here, and we will see those later in the code, and you'll understand why they are there. So if we're moving to the next line, we need to reset LX to 1160. LY will increase, pushing the Y cursor further down. So it's going to increase by 25. And then we are going to update our X and Y attributes on the series label to, because we don't want to have the series label at the top left of the first line and then have the corresponding color box at the bottom right in the second line. We want to reposition the whole series label so that the label and the color box can always be next to each other. So X will be LX and Y will just be LY, because we've already updated them in the preceding two lines. And then we're going to update the mask. So here, where we were originally setting it to top mask, we're going to set that to top mask multi-line. And we created that in the most recent video. And then we're going to do our basic cursor movement. So we're going to say LX decreases by W, shifting to the left. And then we're also going to move it again. So LX minus equals 22. And so that just allows a little bit of breathing room between the color box and the text label. Now we're going to get into creating the color box. So we'll call that series color. And that is going to be a rectangle. Okay, we're going to set some attributes here. We're going to set pretty much the same attributes as before. We're going to set ID, X, and Y. We're also going to set width and height. So this is going to be a 16 by 16 rectangle. Our x position is just going to be Lx. Our y position is going to be Ly minus 16 to make up for the 16 in height for the element. And then I'll duplicate that line. We're also going to set the style. And we are going to set the fill to be the color of the series. So that's going to be graph data dot series at position s dot color. Now the ID is going to be series underscore color underscore. And by the way, these IDs are not actually being used. I'm just choosing to set them so that if I'm scrolling through the code, I know what the element is. And then the next thing we're going to do is we're going to add a little bit more breathing room. So we're going to say Lx minus equals 24. And then one more thing we need to do, we need to attach our color box to the container. Just like that. So I'm going to go ahead and save. That should complete our series labels function. I'm going to do a quick check here. I don't see any errors, and we do see in the top graph, we see a 2-line series labels area, and then in the second one, we see an example of a single line, and single line. So that looks like it's working. I see different colors, so it looks like it's picking up the colors, and the labels are all different, so I'm sure it's picking up the name correctly as well. Okay, I think, yeah, we're going to save these for future videos. We will look at the formatting now, and then we'll probably call it good after that video, and we'll do the automatic Y scaling in a future video. So let's look at this function, which is to format a data value, the purpose of which is to format, for example, tooltip data. So this is going to be fairly simple. We're going to have an if statement, and we're going to be looking at the units. So that's going to be graph data.y-axis.units. And we're going to say if the units equals %, then we're going to return a special value. Otherwise, we're going to return something else. So if we're looking at percentages, then we're going to return the float version of the data value dot toLocaleString, and then first parameter there is going to be en dash capital U capital S, and then we're going to pass in minimum fraction digits 2. So in other words, we're showing a minimum of 2 digits there. And then we're going to include the units themselves, which I'm going to copy and paste out of here, which technically this is a static. I could just put the % sign there. But basically what this is doing is most units are going to prefix the value. So like if it's dollars, dollar sign is going to show up before the value. But in the case of %, it shows up after the value, and so it gets some special formatting. So otherwise, we're going to return the units first. So like I just said, we're going to prefix the formatted string with the unit character or characters. And then we're going to take this same chunk here and return that. So that's it for that function. So I'm going to go ahead and tab that one over. I'm going to save, and I think we're calling it. I'm going to refresh and just make sure there's no errors and that nothing looks obviously wrong. Okay, let's look now at format axis values. So this is, for example, formatting the y-axis. Let's go back over here to the charts real quick. So that would mean formatting these numbers so that, for example, 10,000 here might be 10K. Or yeah, like here, let's say we had a y-axis that was going up to 1,000,000, right? That it might be 1M and it might be 900K, 800K, that type of thing. So this one is rather complex because I chose to make it complex, like, you know, to have all these, especially numeric and financial kind of abbreviations. So we're going to start out with a variable n, and n is basically the number of fractional digits to include. We're going to default it to 0. And then we have an if statement. So we're going to say if graph data dot y-axis dot step value dot index of dot exists, so does not equal -1. So in other words, if the step value contains a dot, so if every step is fractional, then we're going to change our n value. So we'll say n equals and then we're going to take the string value of the step value and then we're going to take the substring and then basically we're going to take this plus 1. So we're just taking the portion of the step value after the dot, and then we're going to take dot length of that. So if your step value is 1.234, then we're setting n to 3. If the step value is 1.1, then we're setting n to 1. Okay, and then we're going to have another variable to store the actual value of the text on the axis at that point. So val is going to be, we're going to parse float of the data value and then say to fixed with n digits. Okay, so now we get into another conditional. And so now we're going to look for if the units is $. So if the units is dollars and units is dollars and n is less than 2, then we're going to make n equal to 2. Scroll down a little bit here. Okay, and then still within the if units is dollars, we're going to have another if statement saying if the min value is greater than 100 or the step value is greater than 100, then we're going to set n to 0. So if graph data y-axis min value greater than or equal to 100, or the step value greater than 100, then we're going to say n equals 0. And then we're going to have another if statement that will set n equal to 0, and that one is going to be if the value of the label itself is greater than or equal to 100. And then we're going to update value again to say that it's equal to basically this same value. Which means I could probably move this. Oh no, I can't move that because we do need val in this condition. So we do need both this line and this line. Okay, and then after that, we're going to start setting our abbreviation. We're going to initialize it to be blank. So the abbreviation is like K for 1,000, M for million, B for billion, etc. So we're going to have some condition. That condition is going to be if the step value greater than or equal to 5,000 or the max value is greater than or equal to 10,000. Okay, so if we're exceeding these thresholds, then we want to add these abbreviations. So I'm hoping that I don't make any typos here, but I probably will. So we're going to parse the value, and we're going to say if the value is greater than or equal to, let me figure out the zeros here, 1 with 10 zeros. So if it's greater than that, then we're going to set the value equal to 1/10 of that. No, we're not going to set it equal to 1/10 of that. We're going to divide it by 1/10 of that. So we're going to say val equals parse int, and then we're going to take that same value, subtract a 0, and then we're going to say val divided by that, so divided by 1/10, dot to fixed. with 0 places. And then we're going to say abbreviation equals B for billion. I'm just going to copy this and we'll say else if it's greater than, and I believe that's going to be fewer zeros. Yep, so that's 9 zeros. And then we're going to say in that case that the value is equal to this to 1 decimal place. Okay, and then I believe we are just subtracting 3 zeros now. So okay, so I believe we have 7 zeros there and 6 zeros there. So basically we're saying if we have more than 10 million, then we want to divide by the number of million and show 1 decimal place with the abbreviation M. And likewise, if it's greater than 10 billion with a B, then we're going to divide by 1 billion, but then not show any decimal places. Okay, so this first one, we're not going to show any decimal places. Let's copy this. And then we're going to decrease it by a factor of 10, showing 1 decimal place. We're decreasing the top one by a factor of 10, leaving this the same, and then showing 1 decimal place, still with the M abbreviation. Okay, and then now it should get into numbers that are a little bit easier to understand. I subtract 3 zeros. So now we're saying if the value is greater than 10,000, then we're going to take value divided by 1,000 with no decimal places, and we're going to give it an abbreviation of K. And then we're going to have a special case at the bottom here where we're going to say if the max value of the y-axis is greater than or equal to 25,000, then if the value is less than because remember the value here is different than the max value on the y-axis. So if the value, so let's say the y-axis goes to 25,000, well, halfway down, well, a third of the way down is going to be about 8,000. So let's say we're a third of the way up the y-axis and we're at 8,000. So that's what val is. So if it's less than 10,000 and greater than 1,000. So between 1,000 and 10,000, then we're going to set the value equal to value divided by 1,000 with 1 decimal place showing. with an abbreviation of K. Nearly done. Actually, that's related, so I'll move that up. Okay, so now we have one last condition, which is if the units are percent. So if the units are percent, then we're going to be returning kind of similar to the function below. We're going to be returning a value and then the units. So that's going to be return val plus graph data dot y-axis dot units. Otherwise, we're going to return the units and then the value and then the abbreviation. And that should do it for formatting that axis. So let's go over here. Let's see how many typos we have. Okay, I was hoping it would be 0. 341. Okay, so this is not a string. Let me check something here. Yeah, so all I have to do here is make sure I'm getting the string representation of that before I'm checking index of. So let's save, refresh. Okay, no errors, but it's not working as we expect. We're seeing undefined. So let's see if we can pinpoint why that would be. Okay, so I'm going to cheat a little bit. I'm going to say okay, so we're gonna log the units, we're gonna log the value, and we're gonna log the abbreviation. Yeah, it's definitely being called. Oh, I'm inside this. Oh, I'm inside the if statement. That's the answer, most likely. I wasn't properly keeping track of my closing brackets. Okay, let's try this again. Okay, good. So that's working. So we see here just 1,000 to 10,000, but note that the max here is 10,000, not 25. So we do not expect this to have the K abbreviation. And same here, the max is only 10,000, so we don't expect any abbreviation, but we do see the $sign preceding it, which we did not see prior. So that function is done and it's working properly. So let's do a quick overview of what's left and then we'll close out the video. So all that's left is 2 functions related to tooltips, these 4 functions related to the specific processing of graph data, and and then automatically scaling the y-axis. And that is all that's left in our graphing engine. But I think we'll stop it there. Thank you for watching.